Oh, okay. My name is Zhifang Fan. I'm a student from Nanjing University in China. And this is our team's work named Target-Oriented Opinion Words Extraction with target-fused neural circuit labeling. Our task is about the topic of aspect-based sentiment analysis. It's short for ABSA. ABSA aims at detecting the polarities towards specific opinion targets. This task consists several subtasks, such as first you should try to extract the opinion target. The opinion target is the entities or the features that people should attitude towards. Another subtask is the opinion words extraction. Opinion words are the terms used to evaluate or describing the opinion target. The final subtask is called target-dependent sentiment classification. TDSA. It just is a sentiment. It is a classification towards the given opinion target. Although there are many works and advances in these recent years on these tasks, but there are still some problems that is not resolved yet. And for example, the first problem is that most of the TDSA models tend to use the attention mechanism to implicitly model the relation between the opinion targets and the opinion words. But we cannot we cannot ensure that whether the correct opinion words is attended or not. The second problem is that there are many works just to combine the opinion target extraction and the opinion word extraction as a co-extraction strategy or joint learning, such as double propagation or some multitask learning. But the problem is that although the learning is joint learning, but the result is not extracted as pairs. So the motivation of our work is that can we just directly or explicitly find the corresponding opinion words for a given opinion target, and how good performance can we achieve? So we propose a new task, a new subtask for ABSA. It's called target-oriented opinion words extraction. Given a review and a target in the real sentence, TOWE aims at extracting the corresponding opinion words for this opinion target. So it has two different input. The one is the sentence, and the second is the golden opinion target. So the output is the corresponding opinion words. You can see in the example, and the input is the sentence and the voice quality. And the output is the grade, the word grade. So we believe if this task can be solved well, it will offer assistance for the downstreaming sentiment classification tasks. Then we formulate this task as a sequence labeling task. It's given a sentence and an opinion target. Sequence labeling is to just tag each word using the BIO scheme. Here is the example with the same sentence and two different opinion target given, and the label sequence is different also. And so as to the sequence labeling, we can come up with a very typical solution, such as the bidirectional LSTM CRF model on the top of word embeddings. But this task is not a very typical sequence labeling, because it has two different input, and given the same sentence and different target, the sequence labeling result is also different. So this is the main challenge of this task. The key is just how to learn a target specific sentence representation or how can you fuse the targeted information into the context. So I first refer to a very typical model in TDSC. It's called TDSGN. And this strategy is really simple. It's just split. Firstly, split the sentence into 3 segments. The middle, the opening target in the middle, and the left context and right context. And this strategy use 2 STM and a forward STM. Maybe you can see the direction of the arrow. A forward STM to model the left context plus the opening target, and a backward STM to model the right context and plus the opening target. And the opening target is represented twice, so we just do a average polling. So this model works really well in the TDSC, but this model we tried, it didn't work for this task. We find that the main problem is that it starts the STM from the 2 ends of the sentence, and at the beginning, the STM is not aware of what the target is. So for the words in near the 2 ends of the sentence, the representation is still targeted independent. So it will output the same result for different target. So we just propose a new strategy that just runs the STMs in the opposite directions. That say for the left part we use the backward STM, and for the right part we use the forward STM. So it just seems it works as we start from the inside, the middle of the target words, and to run towards the 2 ends of the sentence. So we call it as the outward LSTM, and it will naturally pass all the target information into its context. So it will ensure that for each word in this sentence, if the target is different, the representation is also different. Actually, in our final proposed model, we use both strategies. We just concatenate the inward STM and outward STM's outputs. This is empirical decision. Maybe one possible explanation is that they can complement with each other and work together as a target-specific bidirectional STM. The final step of the encoder will also include global context, because the inward STM and outward STM and the IOSTM, they are all based on the split of the sentence. So maybe it will lose some information about the whole sentence. So we just use a bidirectional STM to get the HG, and we will concatenate the HG and HIO to get the final representation R, and we will pass the representation R to the decoder for success labeling. As to the decoder, we experiment with 2 decoding strategies. The first is a greedy decoder. We just do the 3-class classification. And the second strategy is use the CRF decoder, which considers the label dependencies. So I will discuss about the experiments. As to the data sets, we build 4 data sets based on the semi-well changes, because in the original semi-well data sets, only the sentences, the opening target, and the sentiment polarities are provided, while the opening words and the correspondence with the targets are not provided. So we just annotate the corresponding opening words for the given opening targets. And then we generate 4 data sets, and from 2 domains, 3 data sets for the restaurant, and 1 data set for laptop. So here is, let me introduce some baselines or compare methods that is very simple. It considers some very simple idea to solve this task. We do this literature survey and only find maybe 2 papers discuss the similar opinion pair problem. The first distance ruler method is, the idea is that it considers the corresponding opinion words is the nearest adjective from the target. And this is a very simple idea. And the second dependency ruler method is used to use the dependency tree-based templates generated from the training data set, and to used in the test data set. This is a ruler-based method, and we also introduce some neural circuits labeling baselines, such as LSTM and BioSTM, but these 2 models are totally target independent. So that means that for different targets, it will have the same output. We also combine the ruler method with the BioSTM, that is the pipeline method. It first use the BioSTM to extract all the possible opinion words and then select the nearest one. The last method is called TC BioSTM. It's also It's also a very simple way to incorporate the target information into the context. It's just concatenate the target vector with each word in the input. So this is the experiment setting. We use the 300-dimensional glow vectors as the word embeddings, and we will report the precision recall and F1 based on the span. So this slide reports the result about the ruler-based methods. We can see that the distance ruler method works really, it's not very satisfactory, and the F1 score is lower than 50%. And the dependency ruler method is better than the distance ruler, but it is not still low. We believe that it is owing to the error propagation from the parsers, and the pipeline method performs much better than the previous two ruler methods. But its precision is much better than its recall. So we believe that the low recall shows that the distance information is not sufficient for this task. This slide shows the result about the sequence labeling models. That is, LSTM and BioSTM are target independent, so they work poorly, and as to the TC BioSTM, it also is lower than the pipeline methods. So we believe that the concatenation is not a good way to incorporate the target information for this task. So this slide is the last row is the result of our proposed model, and it achieves the best performance, and the improvement is very significant. And we think this result shows that the IOG is a very effective way to capture the correspondence. This slide shows some variants of components of our model, such as the inward STM, the outward STM, and the IOSTM, and the IOG plus CRF. All the previous methods are based on graded decoding. So we can see that the inward STM the performance is not very good, and it is similar to the target independent BioSTM. But the outward STM exceeds the inward STM very significantly. In fact, outward STM has outperforms all the previous baselines. As to the CRF, the important is a bit slight. We believe that it is because the opinion words tends to consist of 1 or 2 words in the most cases. So this is we conclude our contribution as follows. We propose a new subtask for ABSA, target-oriented opinion word extraction. We propose a novel model to solve the task, and it performs well. We contribute for data sets based on several benchmarks, and we find that the supervised learning can work much better than the rule-based methods, but you should incorporate the target information properly, and the IOG is an effective way to solve this problem, especially the outward LSTM. So that's all for my presentation. If you are interested in this task, we will release the data and the code in this URL. Okay, thank you. Thank you for listening.
Any questions?
Hello. Hello? No. Yes. Well, thanks. Thanks for saying the data as well. That's very nice. And I have got one question. So you don't detect the targets, right? You use the gold standard targets.
Sorry, I don't got it.
So you annotate the opinion expressions or the opinionated words.
You mean the opinion word is opinion target is given? Oh.
Yes.
Yes, that's
you
correct.
Use the gold standard.
Yes, we use the golden opinion target. Yes.
From the training data.
Yes.
So what do you do with implicit targets? Because talking out of my remembering, I remember that in 2016 dataset there was like 30% of the opinions had implicit targets. So how do you deal with them? Do you remove them or?
What?
So what do you do with implicit targets? Because there are many targets in the datasets that are null.
Where there's no pair, I think you get.
Oh,
you only
yes, we just remove the implicit. Yes, we remove them.
Thanks.
I did a similar task. I was wondering what kind of dependency parser were you using? Did you retrain your dependency parser to
We use
your
the
data?
SPACY, I guess.
SPACY?
Yes.
Have you considered retraining your dependency parser with like in-domain data, which would give you much better results?
Maybe.
Okay, let's thank our speaker again. Thank you, everyone.